Yeah, next slide, please. So, Venture Center is India's leading inventive enterprises incubator. Next slide, please. We are a Section 8 a non-profit incorporated as a EDC, and we are approved by NSTEDB and BIRAC India. And we are the first incubator in CSIR. Next slide, please. So our mission is to nucleate and nurture technology and knowledge-based enterprises by leveraging scientific and engineering competencies of institutions in the region. And we are focused on promoting inventive enterprises, spin-offs from R&D institutions. And you can see here we are sector agnostic, and you can see our focus areas here. Next slide, please. So this is a snapshot of some of the success stories that we have had so far. You will see some familiar names like Nobel Exchange, MyLab, which played a very crucial role during COVID, Green Pyramid, and others. Next. So just some figures, I'll just highlight that we have more than 15 years of experience, and at any point of time, we have more than 170 resident incubators, and we have a team size of more than 50, and our special strengths are in IP facilitation, technology transfer, regulatory facilitation, advanced prototyping, and analytical facilities. Next, please. So again, the impact, I will just point out that we have mobilized a revenue up to 1,378 crores in the last 7 years. Next, please. So basically, we provide a comprehensive support to promote early stage ideas, startups, and entrepreneurs through a diverse and very impactful ecosystem. Next. These are the various ways by which we help early stage entrepreneurs. We handhold them from preparation stage to scaling up stage. Next. So this is a snapshot of our incubators whom we are very proud of. As you can see, we have in various fields like health, engineering, green energy, agro industries, and we have names like Serigen, Craft, Vidcare, and others. Next. This is a board of directors, as you can see. Next, please. So our key founder and mentor, Dr. Premna, who is a constant mentoring support to all of us. Next, please. So these are our supporting partners, like we have BIRAC, TIFAC, Bill and Melinda Gates Foundation, who have supported us, National Biopharma Mission, DSIR, etc. Next. These are our CSIR partners. So you can see a snapshot of all of them. Next, please. You can connect with us on all our social media handles, which are listed here. Next, please. So I'm going to briefly talk about TechX. TechX is a technology transfer hub at Venture Center, and they are supported by NDM and BIRAC. Next. What we do here at TechX, like I said, we are a resource center of Venture Center, and we are designated as a regional technology transfer office by BIRAC and supported by National Biopharma Mission. We support technology commercialization journeys, and we also facilitate exchange of ideas in science and engineering based field. Next slide, please. So how do we do this? We have various services like technology commercialization, policies, IP protection and decision support, and industry academia partnering. Next slide, please. So the TechNet program is an umbrella of services which we give to our industry clients. And like I said, TechX.in is a non-profit and independent RTTO supported by BIRAC. And we operate through the EDC and Venture Center Pune, and we aim to build mutually productive relationships between industry, and research institutes. Next, please. We do it through various services which we have specifically designed for industry, like TechNet Connect, wherein we give services like technology identification, scouting, technology facilitation. Next, please. And TechNet Initiate, where we do scouting, facilitation, and project agreement. So we have even services like Lead to Deal, where we help in facilitation and project agreements. Next, please. In addition, TechX.in, like I said, also provides services for IPR protection, IPR filing and support, IP advisory, decision support, etc. Next. And I'd like to end with, we're very proud of the award which we have received for our National Intellectual Property Award 21-22. So with this brief introduction, we will now listen to a video which will set the preamble for this event. Thank you. Over to you, Pratna.
Yeah, so
just two instructions for the participants. Since all of you all are on mute, if you want to say something, please type it in the chat box, or you can raise your hand. And at the end of each pitch, we will have an expression of interest in the chat box. So please keep your eyes open for that. Thank you.
good afternoon to all the participants. Welcome to the Technology Showcase on Sustainable Ingredients for Food and Nutrition. I am Pradnya Aradhye, working as Senior Specialist Innovation Management at Venture Center. I'm going to tell you briefly about our Matchmaker and Showcases, which is a pro bono effort driven by our team. Our technology matchmakers are aimed at theme-based matchmaking between technology providers and technology seekers. On one hand, we have technology providers who are from publicly funded R&D labs or academic institutes, and on the other hand, we have technology seekers who could be from industry, corporate, startups, investors, or even budding entrepreneurs. The intended outcomes of this entire effort and the showcase is to have technology licensing deals, co-development agreements, sponsored research projects, new venture creation, or spin-out and startups. This is the fourth matchmaker and the fifth technology showcase that we are hosting and conducting. For every matchmaker, we create a dedicated website and everything is managed through this website. On the screen, you can see the snapshot of website on the left hand side and the link for this website. We also create various marketing collaterals to publicize this matchmaker and to call proposals, which is on the right hand side of the screen. We also put the technology showcases, once done, the technology pitches on this website so that it remains on it and people can visit later on as well to have a look. Let me explain you the process of these matchmakers. It starts with identifying a theme for the matchmaker. Then we put together a group of advisors who have relevant expertise in the subject as well as industry exposure. Advisors are really important to us as we rely on their networks as well to get connects with seekers and providers for a particular theme. We then open a call for technology submissions from providers. This call is announced all over India. We also contact relevant industry people to align them for the upcoming showcase. For this matchmaker, we reached out to more than 50 technology providers and we finally got 15 technology submissions. We have also reached out to more than 80 industries for this matchmaker. The next step is to shortlist technologies for the showcase day. Here we seek advice and guidance from our advisors. Once the shortlisting is done, our team curates the technology pitches, works with the technology providers to create their technology pitches, and then they present during the showcase. The outcome expected out of the showcase is having an expression of interest from the industry side, that are technology seekers. Once expression of interest is received, our team then does the lead management and the relevant agreements. For today's technology showcase, we have technology providers from 4 institutes: ICGEB Delhi, CSIR IHBT, CIAB Mohali, and CSIR Imtech. From the technology seeker side, we are expecting representation from Godrej, Marico, Britannia, Doler, Reliance DSM, and many more. Few of them have requested to keep their names anonymous. For this matchmaker, we have received guidance from very accomplished set of advisors who have collective experience in science, technology, industry connects, projects, and commercialization. Today we have with us our advisors. They are Dr. Vilas Sinkar, who retired as Vice President from Unilever. He was heading their R&D division. Dr. Vidya Gupta, she is Emeritus Scientist CSIR NCL and NAS Fellow. Dr. Guru Swami, who is a professor at IIT Bombay and also ex-scientist CSIR NCL Pune. Dr. Premnath, he is Head NCL Innovations at CSIR NCL and also our Director for Venture Center. Dr. Sanjay Nene, CEO and Founding Director at Innovation Biologicals Pune. It is a startup. He also happens to be ex-Chief Scientist from CSIR NCL. And Dr. Satyanarayana Kandukuri, he is Vice President, Life Sciences Advisory Group at Sadhguru Management Consultants. Today, we are going to witness 6 pitches in total. Each pitch will be of 10 minutes, followed by 5 minutes of question and answer. Outcome expected will be an expression of interest from the seekers. As you can see on the right hand side, this is how the expression of interest form looks like. This is a non-binding, free, very simple form to fill. We will be posting the link to this expression of interest form in the chat box periodically after every pitch is done. And that is all from our side, and hope you all have a very interesting time ahead listening to our curated pitches. Thanks for your attention. Welcome all. So with this, I would now request Dr. Premnath to kindly say a few words for today's technology pitches that we are going to witness, and we would then start with all the technology pitches. Dr. Premnath, please.
Well, good afternoon, everybody. Thank you for joining in, and thank you to our team for putting this together. Very happy to curate this particular tech showcase. Just a brief few points. The first thing I want to tell you is that the theme of the showcase is sustainable ingredients. And we have seen a lot of industry interest in sourcing sustainable ingredients, and and many people who are trying to supply some of these ingredients to the large manufacturers as well, and as well as to the end users. It is in this context that we initiated this. Also, it is our effort in building an ecosystem for sustainability in this country, and to facilitate industry academia interactions on this topic. So this is something which we are very happy to do. This will be done in parts. Today's focus is primarily on ingredients used for food and nutrition, whereas in future we will be looking at some other domains, including those used for personal care products, FMCG sector, and so on and so forth. So that is the plan as of now. As TechX, we are a regional technology transfer office supported by BIRAC. We are grateful to BIRAC and the National Biopharma Mission for supporting this activity and helping us build these connects and useful, as we call it, useful collisions between people who can make a technology fly. Some who are the ideators and the creators, and the others who are the doers, who can make it, convert it into products which will hopefully hit the market. Of course, it's a lot of work. It requires a lot of interfacing, a lot of working together in collaborative mode. So this is an effort to make that possible. TechX is part of the Venture Center. The Venture Center is a technology business incubator and a nucleus or a hub for a local innovation ecosystem. And that ecosystem is, of course, anchored in the West Zone around Pune. But of course, today we have reach in 22 states and about 17 cities where we are also having deep mentoring activities with startups as well. That said, working with large industry is also very important, and sometimes certain technologies are more suitable for working for conversion and translation by large industry. So this RTTO hopefully would help to make those possible as well. I'm very grateful to our advisors who have spent some time going through some of these cases and giving their advice and sharing their wisdom and their networks. Today's effort also grateful to the participating technology providers who showed interest, who also put in the effort to try and communicate all of this in language which everybody can understand and not a very technically heavy language as well. Anyway, all of you are welcome to address questions. Especially, I will also request our advisors to provide inputs as we end the pitch, pitches are meant to be very short, very brief. Following that, we can take up some specific questions as needed. So thank you once again. Over to you, Pragnya. You can take it ahead, please.
Yeah, thank you, Dr. Premnath. We would now start with our pitches. So the first in line is Dr. Sudhir Singh. He is scientist D at the Center of Innovative and Applied Bioprocessing, which is a DBT lab based out of Mohali. With this, I would now request Dr. Singh to kindly start his pitch.
Thank you, Ms. Pradanya. Thank you to Venture Center team for giving this opportunity to share our some of works. I hope I am audible to all of you. Please confirm.
Yes, you're audible. If you can switch on your video as well.
Okay. It is there. So thank you very much. Today my talk is on novel process for the manufacturing of trehalose, which is a high value rare sugar. Before starting, I would like to thank this Venture Center team for making all these slides readable and understandable to all. So trehalose is a high value sugar. Please go to next. So trehalose, basically it is comprised of two glucose molecules which are joined with alpha 1,1 bond. It is a high value molecule in three industries: food industry, pharmaceutical industry, and cosmetic industry. In food industry, it is desirable because it reduces freezing point of food products, which prevents formation of ice crystals, and also it prevents proteins and other molecules which are supposed to damaged by freeze thaw method. This trehalose is highly stable in a wide range of pH. Therefore, it can be used in wide range of food products. It prevents start aging. It has water retention capability, and these features actually extends the shelf life of food products. So not only this, trehalose also maintains the polyphenolic content, and thus it maintains the antioxidant property of the food product. It is a low cariogenic sugar. It has less sweetness. So when you are adding trehalose for all the aforementioned qualities, you are not adding too much sweetness that your food product may lose its flavor and quality. So your flavor and quality could be maintained. And according to several studies, if you intake trehalose daily, about 10 gram, it improves your glucose tolerance and mitigates insulin resistance. So it means the shelf life, uh, your lifestyle related metabolic disorders like obesity can be controlled if you are doing intake of trehalose. In pharmaceutical industry, because this trehalose molecule has capability to stabilize cell membrane and proteins, so it can be used as a cryoprotectant. So basically, it is being used as a cryoprotectant agent for protecting our sperm cells, blood cells, human organs for transplantation. It is also useful in cosmetic industry because it is having a moisture retaining capability. So because it retains moisture, so it is a very high value molecule for cosmetic industry also, and it also reduces body odors by degrading the short chain fatty acids. So for that, cosmetic industry also like to use trehalose in their products like moisturizer and other creams and shampoo. But mostly this trehalose is produced from maltose, and it is enzymatic conversion. But the major drawback for industrial production of trehalose is poor thermal stability of enzyme and low product yield. Can you please go to next slide?
Dr. Singh, can you move your mic a little closer to your mouth? There's the mic.
Okay. Now,
Okay.
is it fine?
Yeah, go ahead.
So we have a great market opportunity also because it offers several healthy options in food and beverages industry. I explained previously that it avoids ice crystal formation, and also it extends the shelf life, maintains the flavors. So because of several health benefits, it is a desirable molecule in not only in food industry but also in meat industry, because it protects protein denaturation. So it also gives a good option for creams and shampoo for as a moisture retaining agent. So it has a big market, and according to CAGR report, by 2029 the market size of trehalose could reach up to 330 million. The price is approximately rupees 1000 per kg, which depends upon which may vary according to quality and purity of the molecule. The major global manufacturer is Haishibara, but unfortunately there is no manufacturer in India. Please go to next. So who can be interested? The frozen food product industry can be interested, because we offer a technology, so no import is required. Ingredient has a very good performance. It gives several benefits to your food products. Pharmaceutical industry may be very much interested, because we are making it enzymatically, so bioproducts can be avoided, no contaminations can be avoided, and the trehalose is can be used as a cryoprotectant agent in pharmaceutical industry, and also in cosmetic industry. It can be used as a moisture retaining agent. Please go to next. So this is what about the technology. We offer a technology which is based on trehalose synthase, a novel trehalose synthase variant that can transform maltose. Maltose contains two glucose molecule, where two glucose molecules are connected with alpha 1,4 bond. So this trehalose synthase enzyme, it hydrolyzes maltose and reconnects those two glucose molecules by alpha 1,1 bond, and now it is trehalose. So this trehalose synthase basically is very stable enzyme. So because it uses a low cost sugar maltose, so your raw material is of low cost. Trehalose synthase is a very highly stable enzyme. We offer a very stable enzyme variant. So we could achieve about more than 70% conversion from maltose to trehalose. And right side, this blue box represents a flow chart, and this flow chart represents how trehalose can be made. For example, for the first, you have to express this trehalose synthase in bacterial cells. So you have to produce the enzyme in bacterial cells. Then the enzyme need to be extracted and purified, and then enzymatic reaction should be performed with maltose. So maltose will be converted into trehalose. About 70% conversion, or more than 70% conversion we have achieved with our trehalose synthase variant. And this trehalose then can be purified by using industry economical method, chromatographic method, simulated moving bed chromatography, or separation purification of trehalose. Please go to next. Now this slide actually compares the Haishibara technology, which is commercialized. They make trehalose, and it is commercially available, versus our CIB technology. So this Haishibara basically they uses three enzyme variants obtained from three microbial sources, which functions at different temperature. Like for example, 5 degrees Celsius, 20 degrees Celsius, 40 degrees Celsius. But CIB offers one trehalose synthase variant that can function in a wide range of temperature from 5 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius to 45 degrees Celsius. And it is a it makes trehalose with higher efficiency. For example, you can see the first one, Camelobacter trehalose synthase, achieves 80% conversion at 5 degrees Celsius in 48 hours. Whereas in our case, we could achieve about 74% conversion in 12 hours. Likewise, in 15 minutes, about 60% conversion could be achieved. Likewise, at 30 degrees Celsius, about 70% conversion could be achieved in 3 hours. So we are more, our enzyme is very highly efficient. and not only efficient but also stable also. If you compare the thermal stability, our enzyme is highly stable. An exposure of about 96 R also retains 50% of its activity at 60 degrees Celsius. So it is highly stable enzyme. Please go to next. And if your enzyme is highly stable, you are offering economical method of enzymatic production of your molecule. Currently, we have demonstrated this technology at lab scale, maybe 1 liter. Sample is available, anyone can take. Patent is filed. So application approval is still pending at Indian Patent Office, which takes time. This has been published in a very reputed journal of American Society of Microbiology. Next. Yeah. So next step is we are looking for an industrial partner that could be interested for technology licensing. We can work with digital partner for advancement and upscale of this invention. We can together work with industrial partner for writing a project, also collaborative project for translation of this invention at industrial scale. So anything we are open after a discussion with the industry, because our interest is that the invention which we have done in laboratory should reach to the society. Please go to next. Okay, this is our lab's portfolio. I work at CIAB. We have a team. We have made several inventions which are many of them are granted from Indian Patent Office. Many are pending. We have made several publications. We have well-equipped laboratory. Our contribution to science has been recognized by National Academy of Agricultural Sciences, National Academy of Sciences. These are two very important academies of India. Then Indian Science Congress Association has conferred Hiralal Chakrabarti Award, looking to our contribution to science. Then SRISTI is a very reputed society that has conferred Gandhian Young Technological Innovation Award to our team for our work in rare sugars. So this is the whole portfolio of our laboratory. Please go to next. Thanks to Ms. Pradanya. She is very kind to making all these slides understandable to you all. Anyone can contact Ms. Pradanya about this technology. Thank you very much.
Okay, thank you, Dr. Singh. I think I'll request Pragnya to alert me when the time is out, but let me pose a few questions from the audience as well, right? You mentioned that this is a rare sugar and you know, its primary use is one of the big use cases is where it depresses the freezing point, and therefore, you know, am I right? Is this the, yeah. So there's a question from Sujata Jayaraman, which asks, what is the sweetness index compared to sucrose, and what is the glycemic index?
So sweetness is 45% less than sucrose. Glycemic index is almost equivalent.
Yeah. So this is not intended, I suppose, as something with a different glycemic index. Am I right? This particular sugar.
Yes.
On the other hand, sweetness index, what did you say it was? Can you repeat it?
45% of sucrose.
Yeah. So it is less sweet, right?
Yes.
Yeah. But the use case which is commonly seen is where, for example, in ice creams and so on and so forth, in frozen foods, where you don't want ice crystals forming, you know, you would want to have a mix of natural sugars which prevent ice crystals from forming, and therefore retain the texture and the consistency and the flavor of the product. Am I right?
Yes.
Yeah. Okay.
Definitely.
There is also another question, which is, by the way, if the answer doesn't satisfy you, you can please flag it. Feel free to raise your hand also. We will try and take up some of these questions as well. There's a raise hand button in the reactions button in the bottom. Okay. Another question is about the safety and regulatory scenario for trehalose in India. So can you comment on what do the regulations say about trehalose today?
So it is a safe molecule approved by FDA. It has GRAS status. It is a GRAS status molecule. Mostly such, and yes, in India it is being used. So I will check with FSI it must be there in their ingredient list, because it cannot be used as sweetener, but in their ingredient list it must be there, because all the grass status molecule are listed in FSI.
Yeah. So before I took on the questions, but I also wanted to request our advisors to comment. Dr. Sinkar, did you have any comment before we proceed to the further questions, please? Can you unmute Dr. Sinkar, please? Any of the advisors want to
Dr.
comment?
Sinkar, I have unmuted you.
Yeah.
Okay, thanks, Dr. Premnath.
Yeah.
I have a couple of questions, but I don't know whether this is the time or we should take it at the end. But anyway, I will ask one question, and that is more as a thought than a question. Yeah.
Go ahead.
Dr. Sudhir Singh, see, both you as well as the Japanese company, they make this particular molecule by enzymatic process. Yeah, they use 3 enzymes, you use 1 enzyme. But unless the material produced by you has a unique advantage over them, you might struggle a bit because they are already commercially available in huge quantities. The price is not very high. So what would be useful is to find out what is the unique selling proposition of the material which you produce, and that way you'll be able to connect with the industry much better. Yeah.
Before Dr. Singh answers, I just wanted to, so the price is quite high. There are only very few providers, manufacturers today. And I think that might have limited its use cases as well. So I'm not sure if the price is very low. Am I right?
Price is about 1,000 rupees a kilogram, which is okay, which is not very high either.
But sir, it is not very readily available. You cannot get it, go to market and it is available. Even D-allulose, trihalose, these rare sugars are not, it is not really readily available. You can go and purchase like sugar, like table sugar.
See, what I would suggest is we'll take it offline, because there are a couple of manufacturers, and the name you mentioned, that Japanese manufacturer, who is quite a large manufacturer. So material is already available commercially. Then it would depend on what is the Indian requirement. If you can get that, then we can discuss it later. Sorry, I took a lot of time.
No, that's perfectly fine. There's also, we'll just take another question as well. Is this a more immobilized enzyme? And if yes, how many cycles have been tested? Dr.
So
Singh?
we have not yet immobilized, but yes, because it has high stability, it can be immobilized and we can test it.
Also, what is your starting material for this, for trihalose?
Maltose.
Yeah. And maltose to trihalose, can you give me roughly a sense of what is the value addition that's happening? Pragna, do you have any numbers?
Value addition in terms of economics or what?
Yeah, in terms of economics. I thought Pragna, you had some numbers for that as well.
Yes, sir.
Okay, maltose is of 45. Probably you are asking the same question. Maltose is of 45 rupees per kg.
Yeah.
And trihalose is of 1,000 or more. If you go with the Haishibara website and all, you will get the costlier also.
Yeah. And what is the kind of yield that you get?
70%, more than 70% yield we get.
Yeah.
Conversion yield. Maltose to means if we start with the 100 gram, about 70 gram is converted.
Yeah. Okay, fine. I think we are out of time probably. Is there any other question which anybody else wants to pose?
Dr. Premnath, hello?
Yeah, please.
Dr. Nene wants to.
Yeah, please. In the meantime, I think Pragna, this UI form, I think you have, it's now openable without a login, right?
Yes, yes,
Can you please
it is.
just intimation to everybody. You can use that form without a login now. Yeah, please go ahead, Dr. Neni.
As a quick addition to what has already been said by Sudhir, is that the most important application of Trehalose is in the preservation of vaccines. And since India has now become a very large player in vaccines, it is something which we can't afford to neglect for a very good domestic market, if not an international market. It is used to improve the stability of vaccines during the process um, of treating it, for drying it by freeze drying. And that is one application which occurred to me first, which prompted me to ask Sudhir to do this work. I wanted to just add this point. It's very important.
Sure. There's a question from Abhinav Gupta asking if you're targeting the pharma or the food industry. Of course, this is an enzyme and a sugar which is being produced here with wider use cases. But did you have some specific target market in mind, Dr. Singh?
Pharma is better, as kindly Dr. Nene directed us, said he is always very kind to guide me. Definitely, pharma is a more promising market for India for Trehalose, because we, if it is sugar, we understand Chini is the best option, good is the best option. So therefore, I think in India, these molecules should be targeted by pharma industry.
Well, that might be your, importance in terms of application use cases and in terms of value. But I think volumes are quite high in the food industry. So any manufacturer of sustainable ingredients will, of course, target all possible markets that they can tap, right? Okay, Pragna, okay, there is another question about the scope of IP filed. Do you want to comment on what is the scope of the intellectual property file? That means, does a patent cover the process of making it? Also, I think your organism is unique to you. Am I right?
Yeah, this the enzyme is unique, but in India, any natural molecule cannot be protected. So we have protected the process of making trehalose by using this enzyme.
Yeah. Okay, fine. I think with that, we'll stop here, Pragya. We'll move on to the next one.
Yes, I would request Sharvari to kindly take.
Yeah, thank you, Dr. Singh. Thank you very much.
Thanks, Dr.
Thank you
Singh.
very much. Thank you very much.
Hello, everyone. So our next pitch is by Dr. Shashi Bhushan, who is a senior principal scientist at CSIR Institute of Himalayan Bioresource Technology in Palampur. The sustainable ingredient he's pitching today is chiconin. With this, I invite Dr. Bhushan for his pitch. Just give me 1 minute.
Thank you, Sharvari.
You can go ahead.
Okay. Good evening to all, and thanks for giving me this opportunity to pitch our technology on industrial production of chiconin and its derivatives as food coloring. I hope I am audible, sir.
Yes, you are.
Okay, thank you so much. Next slide, please. Okay, so I'm talking about chiconin derivatives. These are the, in broader sense, these are the naphthoquinone pigments mainly derived from the plants and also from some fungus. In Himalayan region, it is the Anive euchroma, which is used to extract these molecules from the roots of this plant. However, there are plants like Lithospamum in Japan and China, and Alcana tinctoria in European countries, which is and all these plants of all roots of these plants, these contains these naphthoquinone derivatives, and these are mainly extracted from these plant sources. There is, to our knowledge, there is no chemical synthesis at commercial level in all over the world. These metabolites, these pigments are being used in different industries like cosmetics, food, textiles, traditional medicine, phytopharmaceuticals, because these are traditionally used in Himalayan region, especially in Asian traditional system of medicine for lot of applications, and it can be used as a powder or extract into the products. The dominant chiconin in these root powders is the deoxychiconin, which is also there in our product. Next, please. The opportunities, yes, the global natural food colorant market is huge. It's over 2 billion in 2021, and it's growing at approximately 9.3% annual growth rate, and expected to reach 4 billion by 2030. It's the main factors those are driving this industry is the increased demand for natural pigment, especially for food and personal care products, and these offers area of phytopharmaceutical properties like those mentioned here, and these can be have versatile applications like textile printing, dye, hair dye, or many other products. The major global supplier of these natural colors are Hansen Holdings, Symrise, and FMC Corporation, the Color House, and Sensient Colors LLP, and Lycored USA. Next, please. Chiconin-based composition, what it call as chiconin derivatives, are FSSAI-approved food colorant and phytopharmaceutical ingredient as well as nutraceutical ingredient. And these provides red coloring agents and can be used in vast wide products like food, cosmetics, dyes, and pharmaceuticals. The major production is from Lithospermum erythrorhizon and Arnivia euchroma in India and Nepal, China, and especially Lithospermum is known in Japanese. The price of these root powder is very, it depends upon the quality and quantity of these derivatives. It ranges from 3,000 per kg to root extract, which goes up 16,000 per kg. The major supplier of these chiconin derivatives are mostly from China, including Yangling Biotech, Biological Engineering, Shanghai Jinta, and so on. Next, please. About our technology, because why we should prefer it, it's a sustainable system of production, as we are targeting various sustainable goals. So yes, it is we are not dependent upon the natural resources, so we can produce these advantageous roots what we have induced under in vitro condition in the bioreactors, irrespective of geographical boundaries and environmental systems. It will ensure the year-round availability because these plants are generally available at high altitude, above 3,500 above mean sea level altitude, and these are snow-bound area. So it is seasonal availability there in from April to mostly October. But under in vitro condition, you can have a batch-wise production. So you can have a batch per month. So I have a 12 batch in a year. As I have mentioned here, we have the shorter cultivation cycle because it's up to 5 weeks. Otherwise, in nature, it takes around 3 to 4 years to produce some noticeable amounts of these pigments. We have compared these products with our adventitious route, which we have induced under in vitro technologies, to compare with the market available wild source root powder, as well as the plant from where we have induced these adventitious roots. So you can see that deoxychiconin is the major compound. Chiconin is also there, but it's not quantifiable. Maybe there are a lot of reasons, maybe the temperature or drying conditions. And beta-beta dimethyl acryl chiconin, but as compared to wild, and we have the highest these pigment production in our case as compared to both. wild source root powder procured from the market, as well as the mother plant from where we have induced this root. One more thing, that we have not modified and done any genetic modification, which otherwise may be a concern for some person, because most of the people doesn't like these genetically modified products, especially for food and these personal care products. So it is a finally, it's the sustainable technology which help in conservation of our natural resources and no dependency upon environment, because it also affects the stability of these phytochemicals present in these extracts. And we can have a stable batch-wise performance of these phytochemicals. Also, these Lithospermum or Nivea are both endangered, seasonal, and widely grown. There is no captive cultivation for all these things. One more thing, that this is the first, Lithospermum is the first plant where plant cell and tissue culture technology has been developed to produce this phytochemical under in vitro condition. But somehow, because the cell line stability is the issue, so that's why we have gone for organ cultures, which are more stable than cell culture. Next, please. Next slide, please. So this is the overall technologies. You can see that from left-hand side, first is the wild-grown plants, from where we have established the in vitro shoot cultures, and the leaves of these shoot cultures were used to induce these roots. And from roots, we have multiplied under in vitro condition these roots under different smell, and then produce in these suspension cultures. And then in bioreactors, you can see the color production inside this vessels, and these are the indigenized bioreactor, much cheaper than the what conventional bioreactor being used. Next, please. So who should be interested? Yes, the food pigment suppliers, the food and personal care processing industries, cosmetics, phytopharmaceuticals, and mostly the chikungunya suppliers. Next, please. So this technology is already the patent has been filed for these technologies, and we can produce these technologies at 5 liter. And now at present we are producing it in 10 liter bioreactors and working on 20 liter. Next, please. So we are looking for the partners who are interested in licensing this technology or hand-holding this for the scale up, as well as the raising third-party funds for collaborative projects. Next, please. So I had over 15-year experience of working on plant cell and tissue culture technologies, and we are producing a range of phytochemicals, including picrosides, naphthoquinones, bell-potreates from different high-altitude medicinal plants, which are endangered to that area. And I had also experience on working on phytopharmaceutical formulation, nutraceutical formulation, and value addition of all these phytochemicals, especially in bioprocessing and bioreactor technologies. I am working for past 20 years. Next, please. Next, please. So IHBD is well connected with the different industries, and we have over 50 entrepreneurs who are working on different area. You can see these the logos of different companies which are engaged with IHBT for different food and pharmaceutical products, cosmetics, and immunity boosting nutraceuticals, and range of other products. And we are well connected with the industries as well as the MSME of the government of India. With this, thank you so much.
Okay, thank you, Dr. Bhushan. Before we go to the questions, I will just request if our advisors have any comments, and then we will go from there. I just wanted to point out that so this is a particular product, which is a high value product, which is today, you will have to basically go in the wild, get the roots, grind it, and use it as such, right? And what you've been able to do is do it in sort of create an industrial process, which is an in vitro process, to basically be able to produce this in larger quantities. And therefore, it removes the seasonal variability, requirement of waiting for seasons to come up, right? And also uncertainties relating to supply chains. And also, this plant is an endangered species. So that again poses, that's something which one has to do something about as the volumes increase. So this is basically a reddish food colorant, isn't it? A dark reddish food colorant, which is very popular in certain food applications. So the first question, before I come to the questions, I just wanted to ask, does Dr. Sidkar or Dr. Nene or Guru have any comments? Maybe you can just use the reactions button, or let me know if you have any comments. Sharvari, would you please unmute them if you can?
Yeah, just.
Dr. Premnath, this is Satya here.
Yes, please. Yes, Satya. Please. Oh, Satya, welcome to this as well. Sorry, I missed you. Yeah, please go ahead.
I just wanted to, since it's a existing compound, but I just want to know, since the process is new, or depending on the process, is there any change in the stability of the color in terms of stability to pH, light, or oxygen? Because that's very critical for natural colors to be used in food industry.
Yeah, Dr. Bhushan. Yeah, Dr. Bhushan, please go ahead.
Yeah. I must inform you that we have understand the stability, phytochemical, metabolic stability especially, and color values, hunter values, and product formation. So temperature, that means temperature processing, different temperature processing. So it's working well as compared to parallel to what is available in the natural system.
But I suppose, as Satya is suggesting, you probably will have to work with your industry partner, to a prospective industry partner, to do a little more testing on stability of some of these colors as well, right?
Yeah. So that work is already under process, sir. Maybe within 1 month, I'm going to get all this data.
Yeah. Okay. So there was a question about, there's a question from Dr. Ashwin Gajra saying, what is the unfair advantage of this technology? That means, what is the edge that you have? Technology edge. What makes you stand out?
It's independent of all these, I can say, the uncertainty of the environment, land, and what I can say, the demand supply chain.
Mm-hmm.
So it's if we are going to scale in industrial production up to 1,000 or 10,000 liter, we can go for that. But in nature, you can't do that. So you are totally depending upon the critical endangered species plant material.
Mm-hmm. Yeah,
for these phytochemicals, these pigments.
Sure. Sharvari, can you go back to the second slide which had about applications of Shikonin, yes, right? So there's a question on another question. In addition to colorants, are there any other functional properties explored for certain medical conditions? In what kind of other nutraceutical applications? Sir. Can you comment on the other applications? Yeah, please go ahead. You can comment on the other applications.
Yes, there are a number of applications in phytopharmaceutical as a phytopharmaceutical ingredient. So I have shown you next slide, please, in which we have shown different activities of these pigment molecules, even anti-cancerous, anti-inflammatory, especially for nourishing hair, cosmetics, and you can see skin protection because it's high altitude plant. So generally UV protection is one of the major function of this phytochemical. And there are reports that it's working as a good anti-cancerous products, anti-diabetic product.
Mm-hmm. Okay. Also, is there some way to ensure that this technology is not easily copied by others?
It's because it's totally what I can say, plant cell and tissue culture technology, which can be replicated. But because I'm working for past 8 years, it's not so easy to get induce all these AR without genetic modification. So I can't say other than this that yes, but it's easy to scale up because
yeah. So I mean, I think you have developed a set of process steps which you think has its own. It's difficult to copy easily. People do it with hairy root, or may do it with
there are reports,
culture,
but no commercial setup is there.
Yeah.
Since 1984, people are working on this.
Yeah. Okay.
After lithospermum. Yes.
Okay. So I think Pragnya, with that, I think we should.
I think we have one question from Dr. Sinkar. If we can take that up and we can move to the next.
Yes, please. Please do.
Dr. Sinkar.
I think that question was already asked, but I will just repeat it. I think it is important to look at the pH stability of this molecule because it has tremendous applications both in foods as well as in personal care. And what might come in the way is how does it react to different pH and oxygen conditions. So have a in-depth study of that, number one. And number two, just a suggestion. If you can think about an elicitor, yeah, which can induce this particular molecule production in your root culture system, that may increase your yield quite considerably. And there are elicitors known for other systems. I don't know about this one. Just
sure. I think we got most of that. So thank you very much for those suggestions.
Yes, sir. No. We are already working on, sir. Thank you so much for your suggestions. Yes, that's how I have replied that we are working on stability, especially stability on different conditions. And the work on elicitor is already there in the process. So we will increase that pigment yield again more than that 3 to 4 times now we are getting. I'm hopeful that we are maybe around 8 to 9 times higher yield in vitro per batch.
Thank you.
I think Pragya, you have put out the form for the EOIs, non-binding EOIs. So
yes,
please use that. I think we'll move on to the next one now. Thank you, Dr. Bhushan.
Thanks, Dr. Bhushan.
Thank you, sir. Thank you for giving me time.
Yeah, we will come back at the end to just at the end of all the 4 cases to just 5 cases to just review it a little bit. So just letting you know that. Yeah. Okay. Let's continue.
Yes, I'm there, sir.
So our next pitch is by Dr. Anirban Roy Chaudhary, who is a senior principal scientist at CSIR Institute of Microbial Technology in Chandigarh. The technology that he's offering today is a platform for encapsulation of nutraceuticals as functional foods. With this, I invite Dr. Anirban for his pitch. Just give me a minute, I'll share it. Can you see your slide?
Yeah, I can. Thank you so much. Good afternoon, everybody. First of all, thanks to Venture Center and the team for giving me this nice platform to interact with industry people and the experts in the field to probably better our work. Today, I am going to talk about, we have created a technology platform for encapsulation of nutraceuticals as functional foods. And I'm going to talk about the same in detailing for next 10 minutes. So first of all, let us talk about encapsulation. Next slide, please. And encapsulation is nothing new in case of food industry, especially. This is being used right now all over the food industry. It has several purposes. It masks unwarranted properties like unpleasant odor or taste. It is used to enhance the shelf life. It is used to reduce the processing damage as well as the storage damage. It is easier for transportation, commercialization of the product. It enhances microbiological stability also, and enhances bioavailability of the solubility of the core components also. However, at present, if you look into the encapsulated matrices which are used are mostly from chemical origin. And they are having low encapsulation efficiency and loading efficiency, as well as non-specific delivery is another big problem with this material. Synthetic materials or chemical materials may have some allergic responses causing problems. So we thought, what if we actually start generating some biodegradable, biocompatible, non-immunogenic systems for such kind of materials, which will actually respond to stimuli and help us in giving targeted delivery, and will not have any toxic chemical crosslinker used in this, and probably in the latter range where it will help in co-encapsulating multiple active bioactive compounds. Next slide, please. So keeping this in mind, we look into the opportunity in the market. When we look into the food encapsulation market, it's really pretty big. In 2019, it is recorded around $34 billion. With a 7% CAGR, it is expected to reach around $55 billion in 2026. The major factors which drive the growth is improved shelf life of the end product, reduced nutrient loss, improved heat and oxidative resistance, and targeted delivery. There are few major players, Cargill, DSM, IFNAF, Givaudan, etc., who are actually already in the market. Along with this, when I was looking, our group was looking into this food encapsulation market, another thing was hitting us, was going in back of our mind, was actually probiotics. Next slide, please. Next slide. In probiotics, normally you see probiotic drink is there in market. There are many probiotic drink. You can consider Yakult, and there are so many others, and they have a huge market also, $13.65 billion, and they are expected to grow by 6.1% with 6.1% CAGR. And the major factors are digestive health or weight loss, improved bowel movement, health nutrient absorption, and helps also enhancing the immunoregulatory activities. In this context, I will just mention, probably we will get the importance of this statement later on, that fruit-based probiotic drinks are actually having a higher growth rate as compared to other probiotic drinks, and that is expected to be around 8% from 2021 to 2028. There are a few people like Danone, Yakult, etc. They are already in the market, and they are the global players. Now, what we are actually looking at, next slide, please. We are looking towards an opportunity where we convert the fruit juice to probiotic fruit juice, and we divide the cold chain system, which is almost necessary for probiotics juices or probiotic solutions. Nowadays, whatever you get in market is, say, if you consider Yakult, that is a probiotic vegetative cells which are available in market straight away, and there is a strict requirement of maintenance of cold chain, and obviously cold chain will enhance the cost of the final product. Moreover, when you look into the fruit juices, they are kept in without cold chains in Tetra Pak system. However, if in the morning, many of us have actually habit of drinking fruit juice for our health. If that fruit juice is fortified with probiotic, that will enhance that nutritional quality a lot, and it will help the whole system, whole immune system. If gut is good, then everything will be good. It will help the whole immune system to develop better. There are certain products, not in India. This is a typical product photograph. You can see Tropicana probiotics. This is available in abroad, where it is probiotic fruit juice. However, it requires refrigeration and the shelf life is only 7 to 10 days. So looking at this context, we try to dig a bit deeper into it. Next slide, please. Next slide. So we thought nutraceutical companies who are looking to mask undesirable color, flavor, taste, and enhance the shelf life of the products, they can be interested in such kind of product, which will actually help in enhancing the functionality, health benefit of fruit juice product. So we tried to make a functional beverage. Next slide, please. Next slide, please. We tried to make a functional beverage by using well-known microbial polysaccharides, we took gelan and kappa-carrageenan to form a composite hydrogel beads, and we encapsulated probiotic spores into it. Initially, we tested the leaching and of these things in a model system where we have kept 3 different pH: pH less than 7, pH equal to 7, and pH higher than 7. Then further, we took into a real system where we took a fruit juice as well as coconut water as our model system. Further, we subjected these mixtures to a simulated digestive tract where simulated mouth phase, simulated gas phase, and simulated intestinal phase. We divide it into 3 phases. And if you look into the release of the probiotics, you will find the overall more than 90% spores were actually released here. And one point I would like to mention here we are not using vegetative cells, we are using probiotic spores. And you can see there will get a maximum colonization in case of simulated intestinal phase. Next slide, please. Next slide, please. So further, when we compared encapsulated and unencapsulated spores, you can see the majority of around 50% or even more than that, spores are actually killed by the time it crosses the gastric phase or the gastric phase. And hence the survival is very low in case of these things. And however, in case of encapsulated spores, we get close to 90% or 90% plus in some cases. As per our study, spores remain alive in the gut. Now, when you look into this right-hand side figures, you can see this is the unencapsulated spore in the column 1, and column 2 is encapsulated spore. If you come down, the first photographs are D and G are in mouth phase, and then you come to E and H, they are in the gastric phase, and finally it is in the intestinal phase. That is what matters, that is the gut. You can see unencapsulated spore results in a very low colonization as compared to simulated intestinal phase. And here also, you can see the surface of beads are actually opening up. Next slide, please. Next slide. Similarly, we have tried to go one step ahead. Along with the spores, we have actually encapsulated folic acid. So it's a double encapsulation, and we try to give it in the similar kind of system and try to see whether we can actually provide spore and folic acid. You know, folic acid is extremely important for, especially for pregnant ladies. So it can, and pregnant ladies often have digestive problem also. So we thought a mixture of polysaccharide, a mixture of spores and folic acid will be a fantastic thing to supplement for such kind of population. Next slide, please. So the technology status, if you look into it, we have already fabricated it in lab scale. We have checked in vitro releases. We are now trying to do optimization of the material for 3D printing to create the actual formulation, because whatever we have done in lab scale, and then we will go for in vivo studies for technology transfer. The right-hand side, you can see a few representative publications from our group. Next, please. So I come from CSIR Institute of Microbial Technology. We are probably one of the youngest CSIR lab, and we are always in the forerunner in the domain of microbial biotechnology. And we work in the area of bioprocess and fermentation development. And you can see this left-hand side, this shows the different industries with whom CSIR Intake has collaborated in recent times. And if you want to be too specific for our group, next slide, please. Next slide. Our group, actually, this is, I am working in CSIR Intake in a development for bioprocess development. My expertise is bioprocess development. We have successfully delivered several industrial projects in recent times. You can see all those things in nature. We are extremely industrial friendly. Next, please. So the target is that we have actually created the platform, and now this platform can be used in the similar way or in a modified version. Not only for, we have just taken 2 examples, we can look for other options also. If industry has something else in their mind, we are looking for industrial partner for technology licensing and commercialization. Next slide, please. For more information, you can kindly talk to Dr. Kavita Parekh. Thanks, Dr. Kavita, for all your help. That's all. Thank you.
Thank you very much, Thank you very much, Dr. Anirban. I think we'll go to questions now. But before that, I just wanted to, first of all, just restate what you mentioned and just confirm that that is right, which is that if you have, say, a fruit juice, which you want to convert into or add probiotic properties to it, you will need a mechanism by which those probiotic organisms can be kept alive and active till it reaches the gut, right? And
Yes.
that is what you would be able to do. So your group basically has capabilities in such advanced microencapsulation and such encapsulation techniques.
Yes.
And has materials which are safe materials, well-known commercial materials, which you can tailor such solutions.
Yes.
Right.
Yes.
Now, if and of course, the fact that the cold chain is not needed is also another value addition in this case.
Yes. Yes.
Right.
Yes.
Okay. Now let's move on to some comments first. I'll request Dr. Simkar to go first, and if Dr. Nene is there, he can go next. If anybody else wants to comment, Satya or Guru, please let me know.
Yeah, thanks, Dr. Premnath. Dr. Roy Chaudhary.
Thank you, sir. How are you?
It's an excellent work. Yeah, I'm good. Thanks. It's an excellent work. And it certainly bridges a gap of unmet need. Yeah. Because how to deliver some of these goodies in a stable form, in liquid formulation under ambient conditions, has always been a challenge. So from that angle, I think it's an excellent work.
Thank you, sir.
Just one query. Have you looked at the ambient stability of your encapsulated spores or spores plus folic acid in whatever format, in say fruit juice format or the coconut water format those you used?
Sir, actually, what we did accelerated spoilage studies, as we do in case of food science. So we have evaluated the studies at 3 different temperatures to be specific: 25 degrees centigrade, 40 degrees centigrade, and 50 degrees centigrade. From there, we have the data to show that this, once it is encapsulated and put it in the fruit juice, this fruit juice will not lose any single of its organoleptic or nutritional property till 1.5 months.
Okay, that's pretty good. See if you can increase it even further by increasing the strength of your encapsulation, because the shelf life usually runs into minimum 6 months for the
yes, that is what is our target, sir. That is what you said.
Good.
Thank you, sir.
Very good. Thanks.
Okay. Pragna, can you tell me if Dr. Nene or Satya are there and would like to ask?
Yes, they are there. Dr. Nene, he is with Sharvari only. So, Dr. Nene, you have any comments?
Yes, it's a very good piece of work. There's no doubt about it. Congratulations, Anirban.
Thank you, sir. Thank you. How are you, sir?
Hello, how are you?
I
just want to ask you, are you restricting all your spores work on lab cultures, or have you looked at bacillus also, which is now...
This is bacillus coagulans, sir.
Yeah. Apart from bacillus coagulans, which is a traditional organism, there are other spores which have been very recently used in conveying prebiotics and probiotics. So I would recommend that you look at this activity also. I'll talk to you independently, and we can...
Sure, sir. Sure, sir. I'll call you up, sir. I'll call you up.
Okay. But good work. Very good work.
Thank you, sir. Thank you, sir.
Yes. Thank you. Satya, is Satya there still? We lost some in between because of poor connectivity, I think. So let me go to the questions then. Yeah.
Dr. Satya was to leave early today.
Yeah. Okay.
Yeah.
So over to Ram Kulkarni's question. Is anything known about the effect of selected polysaccharides on the digestion, or does it have any prebiotic effect properties?
Yeah. Thanks, Dr. Kulkarni, for this nice question. Yes, these the polysaccharides used in this system are very slowly digestible in our digestive tract, and I expect, as all of them are actually made of sugar, whatever slowly they get digest. So I expect them to have some prebiotic properties. However, as of now, I do not have any experimental data to support that.
Mhm. Any other specific questions from anybody in the audience? Okay, I wanted to also ask you about why you chose to do the second use case where you were loading, I think it was folic acid to go along with the spores, right?
Yeah.
And
Yeah.
what was the use case you had in mind, and what is the, of course it's like as a platform, it illustrates that you can do multiple things. You can encapsulate and deliver multiple things.
Yes.
But that said, did you have a good reason to go with that particular use?
Yeah, the basic reason is that if you look into our country or in general, many times you will see folic acid is not synthesized in our body. Especially pregnant ladies, they need folic acid. So there should be a delivery system for folic acid, and folic acid is actually almost destroyed. Only 10% of the dose actually reaches to the target point while during in the digestive tract. So we wanted to encapsulate folic acid. Now, at this point, one thing came in our mind. You in many cases, in case of pregnant ladies, again, there are digestion problems, which can be sorted out to some extent, at least by a good quality, good gut health. That's what was the inspiration to take folic acid along with spores and then put it in.
And are there specific so there are many, of course, beverages which come along, and there are beverages which claim to also have probiotic properties, like, say, for example, Yakult and so on and so forth. Do they, of course, Yakult is specifically only probiotic.
Yes.
Do you, I mean, you think, so is it's very unusual to find one without.
Hello. Hello.
Yeah, I can hear you. I think.
Yeah, I think Dr. Premnath's connection has dropped. So in the meanwhile, maybe we can take up Dr. Guru Swami's question. Dr. Guru Swami, you may unmute yourself. Dr. Guru Swami? Okay, I'll read it for him. Dr. Guru's question is, could you please talk about how this technology is protected and what prevents someone from using this gelin kappa-carrageenan chitosan encapsulation technology?
Hello, Dr. Guruswami. Thank you for the question. The answer to that question is that, see, this work we have not patented. This is what we are just demonstrating, the capability of our cells and the platform which we can create. We can create multiple similar kind of compositions which can be further patented, provided one industry is seriously interested to take out this kind of. I hope that answers your question.
Dr. Guru Swami, has your question been answered? You can type your message in the chat box. He has a poor connectivity, hence he is not able to unmute. Yes, thank you. Thank you.
Thanks.
Maybe we can take up Dr. Premnath's question when he is able to join again. I think he has some bad line. Till that time, I would request Sharvari to kindly take this pitches ahead.
Yeah.
Thank you, Dr. Anirban.
Thanks.
So our next pitch is by Dr. Shashikumar Rode, who is the Metabolic Engineering Group Leader at ICGEB Delhi. The sustainable ingredient that he is pitching today is astaxanthin. With this, I invite Dr. Rode for his pitch. Just give me a minute, I'll share the screen.
Hi, Sharvari, can you hear me?
Yes, I can hear you. Can you see your slides?
Yeah, sure.
You can start.
So just say yes when I need to start.
Yes, you can start.
Okay, this is the strain we are working which produce astaxanthin, high yield of astaxanthin. Next, please. Astaxanthin, like there are present in different forms, like free forms, which is coming from the petrol product, and these conjugated with some lipid molecules are 3S form. This is esterified natural astaxanthins. So here you can see that astaxanthin is a highly antioxidant product. It is a carbon 40 carotenoid products, and it come in the category of lutein and zeaxanthin. And it has a high antioxidant, even 500 times greater than this super vitamin E. And but unfortunately, it is only 5% in the market. Rest is 95% market is dominated by the synthetic astaxanthin, which is produced from petrols. But this synthetic one is not used for human consumption. So if you see the right side panel, that animal also have this astaxanthin, but they don't produce. They feed on. They get eating this the green algal cells, which has this astaxanthin. There is different kind of green algae producing this product, and synthetic one also, like people convert these this lutein or zeaxanthin into astaxanthin, or they use a petrol product through synthetic method. If you see that flamingo are quite red, when they born they are totally white, but when they start eating these algal cells, they start getting this astaxanthin in their body. That is important for to make their muscles strong. Okay, next page. So the importance of natural versus synthetic astaxanthin is like the synthetic one has this 3 RR form, whereas this natural one has 3 SS form. So the natural one is esterified, and whereas the it is non-esterified, synthetic one is non-esterified, free forms. And so it is restricted only the synthetic one to aquaculture feed, whereas the natural has the this importance in application in food, dietary supplement, cosmetic, nutraceuticals. Productions, we already discussed the natural one coming from the microalgae, whereas the synthetic one is petrol product. So what is mean esterified astaxanthin? It means that it has a fatty acid molecule attached, while non-esterified is free. Esterified xanthan is natural, whereas non-esterified is coming either through synthetic or chemical conversion. So these have different, like in dietary, these make the strong antioxidants and have numerous health benefits. In fish, they produce pigments in fish also and make muscles strong. Like if you see salmon can swim against the stream because they have this astaxanthin, their muscles are very strong. Cosmetics, now people are awareness is increasing. They want the natural one in their cosmetics product. Food coloring also, like natural one is preferred, since synthetic one is not allowed due to have some traces of the chemicals which used for purify. Next, please. The opportunity here, we can see that there's like current market is $850 million in 2021. Data is there, whereas there's a possibility 9 to 14% increment in future. The price which has been through literature has been searched is around like 10,000 to varying to 1 lakh per kg, but it has it containing average like only 10% estrogen content. Major global manufacturers are from either US or it's from China or it's in Europe or in Japan. Whereas in India, there is a EID Pari Tamil Nadu Limited, Tamil Nadu-based companies producing astaxanthin through wholesale material, not purifying these through the microalgae. They're selling whole cell biomass, which has these all carotenoids like zeaxanthin, lutein, and this astaxanthin. They are of the same very close to each other, so difficult to isolate, but all have high good benefit on that. Maybe they're working in synergic way to give better health improvement. Next, please. So there's who could be interested in pharmaceutical, nutraceutical company can use them for antioxidant due to many health benefit. As only natural astaxanthin is approved for human consumption, so it's important to that they can come forward. These protect cells from damage, maybe light and others. These have, and we have the strain which has the higher productivity than existing technology. Supplier to cosmetic company can also take the advantage, like they can add it to provide the protection against UV caused phototoxicity. It required natural coloring, increase demand for natural colors, and which are the fish feeding manufacturer and their supply also can have their stake to use these products. Addition of products in company's portfolio also one could be added. Supplier to food companies, only natural astaxanthin approved for human consumption. So addition of new product in company portfolio, again the same thing, healthy ingredient can be used for if they use natural astaxanthin. Next, please. About this technology, what we do, like we have this two stage, vegetative stage and stress phase. This two phase. First phase, we just proliferate the cells, and then once we have plenty of cells, we stress them. Under stress, they just start accumulating these start accumulating these astaxanthins. So whole cells become red. What is the features here? We have native organisms, which is called Desmorphococcus globusus. It is a screen from the Himalayan region of India. It has the highest yield so far, more than commercial one, 391 milligram per liter of astaxanthin. And this we have optimized like low cost aqua media for its cultivation. It's a non-GMO. So if we compare with the commercial strain Hematococcus pluvialis of our strain HI, we can see that biomass is producing less, but the astaxanthin percentage on cell dry weight basis is 50%, like 51% of cell dry weight. And astaxanthin content is like 391 milligram compared to this Hematococcus is like 7 to 174 milligram liter. Moreover, our strain divide very fast. It take only 8 to 12 hour doubling time, whereas the Hematococcus take around 25 hours in doubling. So that's why it take long time to cultivate to get this astaxanthin. Next, please. So we have this new strain producing astaxanthin, and we have confirmed by TLC and HPLC the content it has. In vitro growth condition and its media has been optimized well. It has been cultivated at lab scale, 2 liter to 5 liter flask level. Samples available if somebody want to test what are the content in there, and the productivity is better than the other existing strain or not is available. And we have passed in public domain this information published recently, this work. Next, please. The next step, we are looking identify a industrial partner who want to take this technology to the into the public or commercialize. We can help further like growth media, stress induction studies, and harvesting technology, which we have optimized. We can share all those things and even help further. Extraction process can be improved further, and we can do even a scale up study like 20 to 100 liter and give the whole techno-economic assessment and development with doing this work. So what we are seeking here, we're seeking like any partner who is interested to take this technology further and scale up, or want to collaborate, or want to take our strain and use as an expert or consultant. So these are the things we are seeking. Next, please. We have cutting edge.
Sorry to interrupt, Dr. Rode. It's been already 10 minutes. If you can just wrap up your presentation.
So this is okay. Thank you. We have expert in the genome editing, metabolic engineering, synthetic biology. We can improve the strains further if one want. We have this cutting edge technology here. All these modern technology which you have in any lab. Next, please. And we already have in the past like collaboration with Reliance, set up their synthetic biology tool. We have provided some biofuel molecule to Chennai Petroleum Chemical Limited, and Avan infrastructure also we have in microalgae. And with Tata Steel, we doing that by synthetic biology. We have modified the strain which can capture these flue gases. This produced during manufacturing of steel. Next, please. So thank you. And Sarvari is Nayak is the contact here for if anybody want more details. Thank you.
Yeah, thank you very much. I think we will head to comments first and then to questions. In the meantime, I request people to put down their questions on the chat box. Dr. Nene, do you want to go first? Do you want to comment?
Sorry, I don't have any comments really.
Yeah. Dr. Sinkar, did you have any comments?
Yeah, just one comment. This looks like a very good strain of microalgae, because I was doing some calculation when you showed your data. Your particular strain that you use seems to produce about 25 times more of astaxanthin compared to the commercial strain. So that's a big plus, really big plus. And with your ability to do genetic manipulation, I think you'll be able to increase the amount. But at the moment, the question is, what is the purity of your final material at the moment?
Oh, this is, sir, we just running the HPLC standards and just looking with the reference that how much astaxanthin is there. Based on that, we're not purifying it, separating. We just running through solvent, doing HPLC and looking how much is the lutein, how much zeaxanthin, how much is astaxanthin. So we have not really like purified this molecule separately.
So the downstream work of processing is yet to be done.
Yeah,
process development for it.
Well, people are just selling this wholesale material. They're not purifying because that's why they said it has 5% or 10% content of astaxanthin in wholesale biomass.
Yeah.
Because this algal cell has other benefits also. They have other minerals, vitamins, proteins. So everything is health supplements you can add here. So then,
Sarvari, can you go back to the slide which has numbers on yield? Because there was a question, so I just wanted to. Yeah, I think there's a question from Gautam Banerjee, which is about the yield. Do you want to comment on it while I show the slide as well? Do you want to comment on it, please? Dr. Rode, do you want to comment on the yield? Question is, what is the yield?
Yield is here. If you see that this is a 391 milligram per liter in 25 days.
And I mean, is there any the way it is made available today in the market? Can you explain how it is made available? In sense, what form is it available typically?
It's available in form of, if you see the left side, this powder kind of things. It's like dried algae biomass. It is not supplied like a pure one. People selling the pure synthetic one. That is easy. That is doing by hexane. It can also be purified through hexanes. But I think if one want to more yield, then they can knock down by genome editing the other pathway and just produce the pure one.
Yeah. Before I go to the next question, I just want to point out that all of these will be available on YouTube and for people to review later as well. So you can do that. We'll put down I think the link has already been put up by one of my colleagues on the chat box. Maybe I'll request that it can be put up again as well.
Yeah, we are also going to put specific pitches on our website, and we'll be circulating that email with all the information. So that would also be available next week.
Yeah, there's a question from Ashwin Gajra. He has raised his hand. Would you be able to unmute him, please? I think you should be able to unmute. Just check, please.
Yeah, he's unmuted.
Yeah. Your question,
hello, can you hear me, Dr. Rode?
Yes, I can hear you.
Yeah, so I had a couple of questions. One is, there are these heterotrophic growth also people do for cultivating hematococcus for astaxanthin. So have you done any comparison with those? Because now fermentation is becoming more popular compared to growing it in photobioreactors. So that is one question. And the other one is, have you worked on any bill of material? I mean, the cost of goods, how much would it cost if you're not done any, say, downstream processing, but at least till the harvesting stage, how much would it cost, to produce, say, a kg of astaxanthin? Thanks.
That's a good question. There's one Egyptian student was working on this, doing PhD with me, and she test this glucose, supplemented glucose, and realized that in 2 gram glucose, the yield almost double. So yes, there's a probability, but that work we have not taken further. And the techno-economic analysis, the question is very important and relevant. But I think
maybe you can just comment on. So the question is about bill of materials. That means what are the raw materials that are used and how much does it cost, and compared to what is produced, right? Clearly the price is very high, so there may not be any relationship between the two, but the cost wise, what is the largest component of your cost? Must be the media.
No, the media are NPK, very cheaper medium, and water, and this just photosynthesis. But if you want to go heterotrophic, then you might go to like glucose and other substrate. So it depends. We have just very cheap medium, and we use a vertical photoreactor kind of things. Those we have not taken outside this algal strain. But in Israel, they're using hematococcus. They grow in salt water and then drain the water to stress the cells and just harvest the cells. So we have not gone to that level.
Yeah. So I think those numbers we can make available separately. Yeah.
Yeah, we can try.
Okay. So any other questions, please? Did you want to ask any further questions? I think was your question answered, Dr. Gajra?
Yeah, partly.
Yeah. Do
maybe
you have any
I
other
can
questions?
take it offline. Yeah.
Sure.
Sure. So only one thing I wanted to know, because this cultivation process that is carried out requires low temperature. It is not ambient. So is there any requirement for separate cooling or things like that for cultivation to maintain it at say 15 to 20 degrees, which is the best for production?
We using normal temperature like 25 plus minus 2 degrees centigrade. So we're not using low temperature because the same culture room is used for other algal species also.
All right. Thanks.
Okay. Great. Any other final comments? Dr. Sinkar, you had your hand up momentarily. Did your question get answered?
Yeah, it did get answered.
Yeah.
I have one suggestion, but I will reserve it for the last. Yeah.
Okay, fine. Yeah, I think we should continue then. Thank you very much, Dr. Rode. Pragna, can we continue further?
Yes, yes.
Yeah.
Dr. Sharvari, please take it ahead.
Yes. So the next pitch is by Dr. Naseem Gaur, who is a yeast biofuel group leader at ICGB Delhi. The sustainable ingredient that he's pitching today is xylo-oligosaccharide, XOS. With this, I invite Dr. Gaur for his pitch. Just give me a minute, I'll share my slide. I'll share his slide. Can you see the slide?
Yeah.
Yes.
Yeah, I can see my slide.
Yeah. Okay. Let's go, please.
Yeah. First of all, I would like to thank Venture Center for giving this opportunity to discuss the current research and products we are making in our lab. And I would also like to thank Dr. Premnath and Pranya helping me to prepare the presentation to discuss it here. Can you look the presentation? Today, I will discuss about the biomanufacturing of XOS or xylobios for which has a high prebiotic potential. Next slide, please. So prebiotics are basically, they are sugar polymers, and they are known to promote the growth of beneficial bacteria in the human gut. So they have XOS. There are different type of prebiotics, XOS, FOS, or lutein. They are available. Among them, XOS, xylo-oligosaccharides, they are considered the best in terms of their dollar per dose requirements. And the industry for prebiotic is very big. Right now, currently, they are growing with a compounded CAGR of 14.9%. So briefly, if you see what XOS does, when you take them as a supplement, they go into your intestine, and the bacteria like lactobacillus or bifidobacteria, they act as a substrate for them to flourish in the gut. And then they make short chain fatty acids, which reduce the temperature in the gut and which enhance the mineral absorption in the gut and block addition of a bacteria, harmful bacteria. They also block infections like pathogen E. coli, Salmonella. Hence, they have a lot of benefits, health benefits, like they reduce infection and antibiotic-associated diarrhea. They reduce the inflammation and exert protective effect to prevent the colon cancer, and hence the bioavailability and uptake of mineral, including calcium, magnesium, and possibly iron. They reduce the risk of cardiovascular disease and promote satiety and weight loss and prevent the obesity. So they have wider health application, and they known to boost the immunity of a person taking the prebiotic. What we have developed so far, these prebiotics, they are available in a rough form, in a mixture in the market. We have developed a biological method to produce these prebiotics, which is XOS, which has more than 96% xylobios, which is not currently available for human food consumptions. And the production of this is an affordable MSP. Please move to the next slide. So as I said, they are the mixture of xylobios, trios, tetros, and so on. But the quality of a mixture is better if it has more xylobios. The higher the percentage of the xylobios, better is the prebiotic. So there are two currently available in the market, which has less than 30% of the xylobiose and which has a mixture which has more than 90% of the xylose. From where they are available in the market right now, people have developed chemical methodology to convert the biomass. They make it from the hemicellulosic fraction of the biomass into XOS through chemical or autohydrolysis methods. But this method has several disadvantages because there is no really control of degree of polymerization. Like xylobiose is how much will be, triose how much will be. The cocktail varies really very differently, and they use very harsh chemical and extreme conditions. And because of these chemical methods, you required very extensive and lengthy downstream processing for human food consumption. And because of this, they also carry the risk of the chemical contamination, which doesn't really make it very suitable or useful for human as a supplement. Please move to the next slide. As I said, the global market is around 700 million, and which is expected to grow for 5%, 2%, 5.2% CAGR. And there are two varieties which has xylobiose less than 30% in this. The cost in the market is around $25 to $100 per kg, which is available as a nutritional supplement for animal feed and other applications. And xylobiose, which has more than 90% of the xylobiose XOS mixtures, the cost is really very high, like 1,000 USD per gram. And it is not really because of its high cost, it can be used as a human supplement, people just using for R&D purpose. So that the factors which driving the prebiotic market is that these prebiotics, they are the natural supplements to boost the immunity and have several health benefits. And they improve gastrointestinal health and gut microbiota. Next slide, please. So what we have done in this technology, we can take hemicellulosic fraction. We have developed a normal enzymatic cocktail formulated in an enzymatic cocktail, which convert this hemicellulose into a mixture of these XOS in which the xylobiose percentage is very high. In an original mixture with this cocktail, we can achieve up to 66% of the xylobiose in this mixture. And we also developed a purification procedure to enhance the concentration of xylobiose in the mixture. And the final concentration we can achieve up to more than 96%. The yield of this production is approximately 8 USD per kg, and we have performed the techno-economic analysis based on the lab scale production in our lab. The yield of the product is approximately 30 grams per liter. And this process, because this is involved no artificial or chemicals and enzyme, this is purely a biological process, which is environmental friendly, and the starting material is hemicellulose. Next slide, please. So this technology, how does it work? We have hemicellulose, you have an enzymatic cocktail, which will convert into a mixture of XOS, which has around 66% of the xylobiose and rest of the other oligosaccharides. Then we have developed a purification procedure also to enhance the percentage of the xylobiose in a mixture up to 96%. The purity of this purified xylobiose, which has more than 96%, we have confirmed checked with the NMR, which confirmed that this xylobiose which we have prepared is pure and it doesn't have any trace of chemical contamination. Next slide, please. So current status is that we have developed it in the lab scale. We have patented it, and one student has submitted thesis on this, and we have not published this in a scientific journal. And if you see here the technology demonstration, what we have demonstrated in our lab, and we can do it if someone is interested, that if you take a 1 kg of the biomass, from that we can extract 220 kg of the hemicellulose, and we mix it with an enzyme formulation which is available with us around 0.4 gram. And then you produce approximately 150 gram of this mixture of one, which has 66% xylose, and further purification lead up to 80 gram. When you calculate the cost, you figure out that as compared to the starting material, there is around 35x value addition for variety 1 and around 8000x value addition for the purified, which has 96%. Next slide, please. So who in people who are manufacturers of ASS, XOS, sugar industries, and manufacturer of prebiotics can be interested is because for sugar industries can be a value added product, and prebiotic it can be expansion of their already available product, and for manufacturing XOS is a low cost process. It is a purely biological process which has a high percentage of xylobiosis. Next slide, please. Next slide, please. Next step is we are looking for industrial partner who is interested in this technology. We are ready to demonstrate in the laboratory scale. The partner can take up the technology at a level we have, or we can in collaboration set up an higher pilot scale plant and demonstrate at higher level, as well as we can do some R&D if further required to fulfill the desired conditions by the manufacturer for this project. Next slide, please. So what I have done, I have more than 20 years of experience working with yeast and molecular biology. I have worked in Harvard and NIH before joining ICGB as a scientist. And my expertise basically is yeast metabolic engineering. And we have more than 50 publications, 4 Indian patents, and we have a very good world-class facility in ICGB, up to 20-liter fermenters. We have mass spectrometry and HPLC and other high-end equipment are available. In past and in current, we have collaborated with Braj, Spectrum Renewable, and CRES. Next slide, please. Thanks. Yeah, if you need, you please contact Pranya for further details on this project. Thank you.
Thank you. Thank you, Dr. Gaur. I think, can you just go back a little to another earlier slide such that we can keep that on while we discuss. I think I'm requesting people to ask questions using either the type it in the chat box or raise their hand button so that I can ask them to ask their questions as well. So Dr. Gaur, of course, you're starting with hemicellulose and then it gets converted to some value added high value prebiotic XOS, right? Yeah. So XOS, can you tell us a little bit about the prebiotic markets and where does XOS stand in that? Because we know about FOS, XOS, GOS, and so on.
Yeah.
Roughly, what are the trends in this field?
The XOS is considered one of the best, which promotes the growth of these bifidobacterium or lactobacillus bacteria into the gut. The dollar per dose value is less for XOS as compared to the other prebiotics which are available into the market. And none of these actually, these are not all biologically, none of them is biologically produced. Probably they all are chemically produced, which has a high risk of taking as a supplement for human health. And the potential for growth is really very high in case of XOS because it has with high content of xylobiose. The more the xylobiose, better is the prebiotic.
Yeah.
So that is not really available because of the high cost. People can't afford it to use as a prebiotic right now.
Yeah. And also as a overall, I wanted to also pick on your general large picture biorefinery program, which basically says that you're trying to basically address multiple things coming out of a biorefinery, right? And one of them being XOS as well.
One of them being. We have a complete solution for a sugarcane based biorefineries here. If you can go to the last slide I had in this, I can briefly in 1 minute convey what we have. Next to last slide. Last. Go in the end, please go ahead. Go ahead. Next. There were few slides in the end. Yes, this one, the upper one. Upper one, please. No, below this. I think second last in which you have
Before this one,
chart.
Sharvari, before this one, there is a flow chart.
Okay, so this is before. This
Yeah.
is HPLC profile.
Yeah,
This
this
one.
one. So what we have actually, we have been working from last 8 to 10 years on these kind of projects in which, and now what we have, like if you take a sugarcane in a sugarcane industry, you have sugarcane bagasse and sugarcane juice. Sugarcane juice you can directly ferment to the ethanol using S cerevisiae, and as well as you can ferment the molasses. So what we have done here, we have a novel strain of Saccharomyces cerevisiae for ethanol production, which have performed the comparative fermentation analysis with respect to angel yeast as well as ethanol red, which are currently available in the market. And this strain has a lot of superior characteristics for ethanol production as compared to them. And we have also developed an integrated process that sugarcane bagasse we can separate hemicellulose and cellulose. Cellulose you can mix with molasses, and which will increase the ethanol in reduced water, which will require for the molasses molasses dilution. So we published that also. And this strain S cerevisiae in this condition also has been demonstrated that as compared to ethanol red and angel yeast at 30, 35 and 40 degrees centigrade, it has much superior fermentation performances. So solid fraction from the bagasse you can convert to the ethanol along with the molasses or sugarcane juice, and the liquid fraction which has hemicellulose and lignin. From hemicellulose, we can make the XOS that we presented. We have developed all technology for this. We developed this enzymatic cocktail, which use here big grown very cheap and technology to hydrolysis. So lignin is a part which is remained unaddressed in our approach, but hemicellulose, cellulose, sugar, juice, we can utilize all of them.
Yeah, there was a question from Dr. Sudhir Singh. Did you want to ask a question? Please, I've unmuted you, I think. Yeah.
Thank you. It's nice presentation, Dr. Gaur. So this, I wanted to know the source of enzyme, because you have used the term enzyme cocktail.
Yes, definitely. You need a cocktail to make a specific mixture of XOS. The raw fungal cocktail generally will convert hemicellulose into xylose. So we don't want xylose, and we don't want higher polymers in higher percentage. So we need a specific particular set of enzyme in a proportional ratio in that cocktail. So we have two methods for that. We have one is a natural and one is a recombinant. We have two cocktails.
Yep.
Yeah. So means how many total enzymes?
In one cocktail, which is rough, it has lots of enzymes, more than 100 enzymes approximately, because this is a rough cocktail, crude cocktail. In another one, we have 5 enzymes, which recombinantly expressed in yeast.
So is it commercially available, or
no,
you are making it in-house?
No, we are making. This is developed in our lab. This is not commercially available.
So is it patented?
Yes.
By your laboratory or abroad?
Yes, our laboratory.
So this xylose, because you said that xylobiose purification you are doing. So to what extent purification is required?
So it is a one-step purification which gives xylobiose, enhanced xylobiose more than 96% in this cocktail, from 66 to 90%, more than 90%.
So I am interested to know that how much this recombinant enzyme is useful for offering this XOS in food industry or pharma industry.
How much in terms of?
In terms of regulation, in terms of.
So recently, all enzymes has been cleared. You know, there is a whole list of this around 40-50 enzymes that government has cleared for recombinantly produced that can be used in a food. They all are cleared now. Yep. All cellulases, hemicellulases, amylases, and beta-glucosidases, they all are clear now, which the enzymes which are being used in food and beverages industry. I think you must be aware that around a couple of months back, DBT released a whole list of those enzymes, government of India.
So Dr. Singh, I think we'll take it further.
Thank you.
Separately as well. I think in the interest of time, I have to proceed ahead. But Dr. Nene, did you want to comment before I move on?
I have a question, in fact, to ask. I think it's very important to understand what is the source of hemicellulose, because Dr. Gaur has worked on bagasse also.
Yes.
The reason why I ask is that, as you know, hemicellulose is a generic term which includes basically xylose and arabinose. So one is, what is the fate of arabinose? And secondly, if at all we are going to separate the arabinose, then what is the eventual recovery of the xylobiose from the starting material?
Yes, sir. I have shown in
percentage of what that on a mass balance if you do. What would be the xylobiose?
Can you go back to the slide, my second last slide probably? I have shown there.
Go back.
Go back.
Back. Furthermore.
Next. Yes, here, Pierre. Please, you see here. If you have 1 kg, if you have sugarcane bagasse, which will give you 220 gram of the hemicellulose and 54 gram of XOS mixture 1 and 80 gram of mixture 2.
Okay, so your 80 grams is the
yes, 80 gram is the one which is purified, and 150 gram is the one which is not purified.
Okay, no, if you express it as the total percentage of hemicellulose, what does it work out? 80 divided by 220? Is that what you're getting?
Yeah, 220 divided by 80. Yeah.
Okay, right. Thank you.
Yeah. Okay, I think we'll stop here. Thank you very much, Dr. Gaur. Let's move on to the next one, which is, I think, the last one, right, Pragna?
Yeah, that is the last one.
Yes.
Yeah, Sharvari, please change the slides first, and then we can introduce the next one. Please.
Sure.
Thank you, Dr. Gaur.
Thank you, sir. Thank you very much.
Yeah. So the last pitch is by Dr. Anirban Roy Chaudhary. The technology that he's offering today is a platform for nanoformulation of polysaccharides for nutraceutical delivery. With this, I invite Dr. Anirban to continue with his pitch.
Thanks, Sharvari. Good evening, all of you. I'm back once again. So today, in this speech, I am going to talk about a platform created in our laboratory regarding nanoemulsion formation by using polysaccharide for delivery of nutraceuticals. All of us sitting here are very much well aware about nutraceuticals, and probably COVID has taught us about the importance of nutraceuticals in our daily food or daily basis. And nutraceuticals are obtained from across different fields. They can be obtained from microbes as well as from phytochemicals. And they have an inherent property of instability. They have inherent property of bad taste and sometimes odor also. So we wanted to address this problem by using polysaccharide-based nanoemulsion. Now, next slide. Why polysaccharides? Next slide, please. Polysaccharides, we all are aware about it. They are basically a polymer composed of sugars, different kind of sugars linked to glycosidic linkages. And they have been, and they are naturally obtained from several sources, like plant sources as well as from microbial sources, very complex in structure with high molecular weight and extremely stable even under harsh environmental conditions. Now, I am specifically talking about microorganisms, microbial polysaccharides. Our lab mostly work in the area of microbial polysaccharide, both for process development as well as application development. Now, we found that these polysaccharides are actually natural, biodegradable, non-immunogenic in nature, and many of them are US FDA. They have found diverse application in food, biomedical, therapeutics, and other things. We can create different kind of materials like hydrogel. I have discussed in the earlier pitch. We can create polymer foams, we can create nanoparticles, we can create emulsions, and we can actually incorporate stimuli responsive behavior. All these advantages of polysaccharides actually pushed us, can we create a nano emulsion of this material? Next slide, please. Now, nanoemulsions are the target of this nanoemulsion, formation of this nanoemulsion is to encapsulate the nutraceuticals for targeted delivery of them. Now, these nano formulations are expected to improve water dispersibility and reduce volatilization, as well as it will enhance the stability of the molecules, reduce the undesirable flavor and taste. It can be controlled release also, and it will not have any adverse effect on the functional foods. Now, these different polysaccharides are actually used for making such kind of nano emulsions. Next slide, please. When you looked into nano encapsulation market, the market is a bit niche even yet, but it is developing faster. It is around $7.8 million in 2021, and CAGR is impressive 8.3% and expected to reach around 14.76. The major driving force is again increased solubility, which will finally lead to higher bioavailability. It will enhance the shelf life, as well as help in controlled release of the bioactives. There are many global players, Cargill, BASF, DuPont, etc., etc. So there are many things many companies which are actually participating in this. Next slide, please. Now, I believe the nutraceutical companies who are using as at present synthetic emulsifiers and may have interest in using biological materials of biological origin, which are biocompatible as well as safe for towards green consumerism, where we will actually mask undesirable color, flavor, and taste, and as well as enhance the bioavailability as well with functional and storage shelf life improvement, especially for in case of processed food. Next slide. So while next slide, please. Sorry, the earlier one, jumped one. Yeah, I've talked about it. Next slide, please. Next slide. Sorry. So now, when we look into this system, so we try to pick up a model molecule. We picked up curcumin. We all know about the curcumin right now. And curcumin has the ability to scavenge anti-ROS, as it can be used as antioxidant. And so we just used curcumin as a model compound. We have used a few other molecules also for the same purpose, but today I'm presenting only curcumin here. So this curcumin is insoluble in polar liquids. So we have to make it solubilize in non-polar liquids. That's why probably curcumin is suggested to be taken along with milk. Now, curcumin emulsions are being formed using synthetic emulsifiers like twins, and in the current study we have tried in polysaccharides. Now, if you look into the data in the bar graph here, you will see normal curcumin antioxidant activity is 61.5%. Whereas this is DPPH method we have used, and if we go for twin 80, the activity actually reduces to 60.92%. Whereas when we used guar and leaven, two very well-known polysaccharides used widely in food industries, we were able to enhance the antioxidant activity to 74%. In both the cases, we are just showing the data here because we have evaluated several polysaccharides in this range, and we are just reporting the best one. So we felt that this will be a good option. Next slide, please. So we have done it already in the lab scale. We have stabilized this emulsifier, and this is the first of its kind study where we actually evaluated efficacy of different polysaccharides for emulsification of curcumin without using any kind of co-emulsifiers. Few of the representative publications from our group are here. Next slide. So as I told you earlier, also CSIR Intake is a national laboratory forerunner in the domain of microbial biotechnology. We have excellent facility for all kind of microbial technology, especially in terms of fermentation and bioprocess. We have a scale-up facility till 1.5 kL, 1,500 liter fermenter, and we pretty closely work with different industry. You can see here we have worked with different leaders in Indian industrial sectors, along with ISRO also. And so we are pretty industry friendly. Next slide, please. Our group mainly works in the area of bioprocess development, and we have successfully delivered several industrial projects like Panacea Biotech, IFB Agro Industries, Rampur Sugar Mills, Excellence Biotech, and Polymers. we are mostly focused in the area of fermentation, that too specific for microbial polysaccharides and some enzymes. Manoj looks after the business development part, and this work is done by Richa and Nandita. Next slide, please. So this is a platform what we have created. We can actually tailor-made this kind of platforms as per the requirement of industry, and we will be ready to listen to the requirement of the industry and place ourselves accordingly. The next step is to identify industrial partner for co-development for proving is techno-commercial viability in the next stages. Next slide, please. I thank Dr. Kavita for all her assistance. Thank you.
Thank you. Sharvi, can you just keep the slides on showing some of the earlier slides which have applications, please? Yeah. Yeah, thank you. So I think I'll begin. In the meantime, I'll request everybody to do a couple of things. One is if you have questions, and if you have, you can type them, or you can press your raise hand button so that we can ask those questions. We'll unmute you as you come along. The second is that there are some forms, feedback links being put up as well. Please try and fill that up. And of course, Pragna has put up a EOI kind of link as well. So we'll please take time to do that as well. Okay, in the meantime, let's discuss this. This actually has very wide application in many cases. There could be many other use cases. Of course, you have looked at a very specific use case. So just to reiterate and understand, you have taken microbial polysaccharides, and these polysaccharides are known polysaccharides. Is there anything?
Yes, they are known and used in food industry.
Yeah. So and you have used those to encapsulate them or nano emulsify them
to create nano emulsions by using those polysaccharides.
Yeah, and those cases where these nano emulsions, especially for those where you'll have trouble otherwise with dispersibility and bioabsorption, is what you're targeting right now.
Yes.
Isn't it?
Yes.
And
yes.
As a use case, you have shown the use case of curcumin.
Yes.
Where, of course, it's well known that bioabsorption is an issue if it is not delivered in the right way as well. Yes. Can you walk us through this conversion of this process from polysaccharide to the nano emulsion? What are the process steps and how have you protected it?
Okay. Basically, the curcumin is water insoluble. So we solubilize it in oil. Once it is solubilized in oil, then we take aqua solution of these polysaccharides, and we stir it for some time at a definite RPM, and we form these nano emulsions, which are further characterized by using transmission electron microscopy. And the size we got is somewhere around 75 to 100 nanometer. And further, we evaluate both things: the ability of these nano emulsions to encapsulate curcumin and put this nano emulsion in a simulated system where we look into the delivery of this curcumin in terms of antioxidant properties.
Yeah. And as far as the stability of these nano emulsions is concerned, how is that normally studied, and under what circumstances does it need to be?
There are standard methods available. We have kept these solutions in our lab. I think we have made it around 6-8 months back. It is stable till date.
Mm-hmm. And did you have to check for stability with different pHs and so on?
Yes,
so
we
forth?
did. We did all those things. Due to time constraints, I have not kept all the data here. We have done all those.
Yeah. So that data is available for
those data are available with us.
Yeah. So did you mention that? Have you filed a patent for this?
No. This is again published. This is again another platform which I wanted to create. This is again published in International Journal of Biological Macromolecules.
Okay. And the formulations that you can do, you can tailor it for a given application depending upon the use cases. So if
Yes.
a company is interested in, say, doing a nano emulsion of a particular nutraceutical or an active, you should be able to create a
Yes, sir.
formulation.
Actually, sir, I am looking into two different angles here. I just wanted to tell you, as you raised the point, that I am looking for both food as well as cosmetic angle also. From cosmetic angle also, this kind of nano emulsions are extremely important.
Yeah.
And unlike chemical emulsifiers, this will not have any allergic responses to our body.
These microbial polysaccharides are easily available.
Majority of them are available in the country, and or are they? Some of them are actually imported from China. In this context, I just wanted to make one statement. I work on a typical polysaccharide which is known as pullulan, have used in food packaging, and other material. So India does not have any technology right now. Everything is brought from China. We have developed a technology and scaled it up to 500-liter fermenter scale, and there are several uniqueness in our process. Most importantly, the cost of the product will be a lot less as compared to the cost even we are procuring from China.
So these polysaccharides are synthesized by you.
Polysaccharides are fermented and produced by us. Yes.
Yes. Yeah. Okay. Dr. Sudhir Singh, you had a question. So I'll unmute you. I hope you can unmute yourself.
Thank you. Thank you,
Yeah.
sir. Dr. Nivasan, how are you?
Hi, I am good.
Yeah, please.
So, sir, it was a really exciting presentation. Just one thing you answered, I wanted to ask about microbial polysaccharide pullulan. So now there are several other polysaccharides like dextran, leaven. What about those? Can they be used for making nanoformulation?
See, we have tested a range of polysaccharides for doing this thing. Among those range, we have screened polysaccharide in one sets. Among these, this leaven has given us probably the leaven and guargam has given us the best result. That much I can tell you.
Leaven has antiviral properties also.
Yes,
but how?
It has.
So this means, have you tested its stability in vivo condition, means within in human body?
In vivo we have not done. In vivo we have not done. In vitro simulated condition we have tested.
So when it comes to nano formulation, do you also intend to use nanoparticles like iron nanoparticles? And
here we are not talking about metal nanoparticles. Metal nanoparticles are already being used. Metal, silver, gold, and all of the different kind of metal are already used. We were focusing here to create a nano emulsion by using polysaccharide, replacing commercial emulsifiers.
And what about the issue which generally comes with nano formulations, that it can cross brain barrier, something like that?
Yes, there is sometimes it is actually a negative for the nano emulsions where it can cross the blood-brain barrier. Sometimes it is positive, sometimes it is negative. However, we have not tested in our case what will happen. I don't know, but I trust that molecules are big enough that it will not cross the blood-brain barrier.
Okay.
Thank you, sir.
Yeah, I'll move on to other questions. There's a question about have you done release studies? Does the formulation slow down release of the API, and how effectively does it do it?
We have done release studies in vitro. We have not done release studies in vivo. And we could find that the majority of the material actually gets released in the gut, not anywhere else.
Okay. And what are the possible triggers for the release? That's another question, follow-up question.
Probably the gut environment and where these polysaccharides are actually can work in the terms of prebiotic and start getting degraded, pores open up, and then they get digested. Moreover, there is certain effect from pH also.
Okay, that's good. So any comments from any of the advisors? Does Dr. Nene or Dr. Sinkar have any comment, please?
I think most of the questions that I had in my mind have been answered by the various people earlier on. My only issue is that, Anirban, you have to develop a good workable model for replacing in vivo studies. I can give you the example of people in the Netherlands who have developed a sort of artificial colon, or, the entire gastric chain, where they test these emulsions that you've made and find out its efficacy. And that would be a very important work that you would need to do if you want to satisfy people from industry that yes, this works. You have to have this method of having a sort of simulated in vivo method of estimating the properties of the microemulsion.
Yes, sir. Thank you, sir. Thank you so much. Yes, what you said is extremely important. I am now trying to create shine in our lab, sir.
Okay, right.
I'm trying to create shine in our lab, which is actually a simulated system for the whole digestion system, starting from mouth phase to gut completely. We are trying, this will need 4 different fermenters under anaerobic condition. We are trying to create that, sir.
Yeah.
Okay, good. Wish you all the best.
Yeah.
Thank you, sir.
Dr. Anirban, is there any are there any steps in this process of making it which are difficult or challenging that will make it difficult for hard for other people to copy it?
No, I would rather say this is probably this, if somebody wants to do it, this is probably one low investment or low initial investment thing. We don't need much larger equipment, not much sophisticated equipment, very simple system. As I told you, we have just done it through agitation only. Nothing,
Yeah.
no other thing we have used.
No,
Controlled agitation.
And also in the process of putting the specific nano emulsions together, right? In the formulations or in the process of getting the formulations right or getting the curcumin in and so on. Is there anything
Not challenging, sir? Not challenging. We have done it so easily, actually.
Okay. So let's continue further. Thank you very much, Dr. Anirban. I think I'll stop here with this. I'll request Sharvari to close this slide and let's have all the advisors in. We'll just take another 5 minutes to close. I will, we'll just have some closing remarks before we can end the session for today. And I think we'll be in time with that. So let's go ahead with this. These were the different presentations we heard today. There were actually a couple of them. Yeah, sorry. Sharvik, you can go on mute, please. Yeah. So there were some which, of course, were focused more on encapsulation, on delivery, in nano emulsions and so on. And then there were 2 which were on colorants and related and applications of such molecules in other sectors as well. And then we had those which were more of sugars and prebiotics as well. So let's go through that a little bit. I'll request our advisors to kindly step in. Can I request Dr. Sinkar is there? If you can.
Yes, I'm there, but let somebody else go first.
Yeah. No. If you can just come on video and maybe Sharvari, is Dr. Sinkar also visible? Yeah. Okay.
Just check. Yeah, he's visible.
Yeah, no, I just wanted first the advisors to comment on some of these technologies. Of course, there is a promise in some of these technologies and there may be some challenges as well as it shapes up, right? I wanted to first request a few comments and then maybe, we can discuss those a few minutes and in 5 minutes. So I hope to close as well. So let's go with that. First of all, Dr. Nene, would you like to comment on anything that caught your fancy out here? I know you have to, I'm asking you to pick, but I nonetheless thought you can say which one caught your fancy in terms of, what could be of industrial importance and which strikes you as something which, should be, and what are the reasons why you would pick that?
Well, I'll just do it very quickly because there are so many issues which are being discussed. But some of the things which I liked very much was, of course, the polysaccharide formulation, which is a very good product and which would have a marketable value provided your polysaccharides are cheap. I mean, he's given the example of some plant polysaccharides like guar gum, and also I know he's working been working in Pulilan for a long time. So I think something which is based on this would be very good. It's rather unfortunate that Anirban, we have not patented anything or put in a provisional patent, because these things are very important when it comes to something which you wish to practice in industry. But
actually, I was doing it. So actually, I was doing it for fun, so got it published.
No, okay. Then Xylobio's, of course, is good. I think the XOS we would like to look very closely at the yields, because I think and the purity, of course, because Xylobio says this almost 96%, more than 96% purity, which is very good, because Xylobio has a good future in the country. I'm surprised if the Tatas are not here in the program, because they are actively working this area. And maybe independently you can talk to people from Tata Chemicals. They would certainly be interested.
Yeah, Dr. Nene, this video will be available to them. We are in touch with them.
Okay, you're in touch with them. Good.
Yeah, thank you. We'll do that. Yeah, please continue.
Yeah, astaxanthin, of course, is a very good molecule. In fact, I was associated when I was a member of the BIRAC team when we visited people who are making astaxanthin from seashells, shell products. But this now the shift emphasis has been for fermentation, and I think the concentration of 370 and 391 milligrams per liters is very exciting. I think we have to see how this can be replicated, who's interested, and I think it's a very doable project. I liked it also very much, and I think that it has got commercial possibilities. Chiconin, of course, has been around for quite some time now. So the beauty of chiconin is that if you can replace it from the field product to a lab product, and but I think it is heavily patented. So Bhushan, you have to look at whether you're in a sort of FTO, freedom to operate in India, but it's a good product. Yeah, and
from what I understand, Dr. Nene, the plant tissue culture method that he's using, nobody else has done.
No, I think it has been done, but because I mean, there've been references to something which is quite dated. In fact, my professor in IIT Delhi, Dr. Ghosh, used to say that chiconin is the only product which has been made by plant tissue culture because it is very good, but because it attracts a high price. But I think you can have things which you can patent in the fermentation. So as long as he looks at the patenting very carefully and sees what he can find which is not covered earlier, I think it should be okay.
Yeah, so I'll let Dr. Bhushan respond on that while we are at it, because
okay, sure.
His comment to me earlier was that hairy root culture once people have tried. But anyway, you can go ahead.
Yeah. Thank you, Dr. Thank you, Nene sir.
Yes.
Yeah. Thank you, sir.
Good to see you.
Sir, yes, it's highly patented, but earlier the efforts were made on cell culture, not on organ culture.
Okay.
So the patents are mainly on cell culture, and that was not a stable system. That's why, yeah, it's actually the first system where plants tissue culture has been established on industrial scale.
Yeah.
But because that industry just failed due to that cell culture system. But if these are the organ culture like hairy root, then it's going to be a stable system, sir. And there is no patent on adventitious root, which I have filed already.
Okay, right.
Yes,
it's nice to know that. Thank you.
Okay, great.
Thank you,
so
thank you.
Let's go ahead. Did you have any more comments?
I know everything but fellows. I don't want to comment it here.
Yeah. Okay. Dr. Sinkar, you had any comments?
Yeah. To start with, I think All the presentations and the content were excellent. I guess all of those have considerable industrial applications. Question is not whether, the only question is when. When will it happen and what needs to be done? And of course, there are different suggestions for different projects we heard, but I will not get into the detail. This is not the platform. I'll write down my comments and send to you, and you can give it to people, to the presenters, and they can act on it. But just on top of my mind, I may say, the first presentation, tree halos, if you can think of making tree halos from starch instead of maltose, you'll bring down the cost considerably. Yeah, by using alpha amylase there. Just think about that. And also think about the medical application of tree halos, particularly for high value cancer biologicals, which need to be kept at low temperature, and also the vaccines, which Dr. Nene mentioned earlier. Coming to Shikonin, which we discussed just now, I think the Shikonin patents that we talked about are fairly old, and many of those may be out of their active life. But I guess most of those patents are with different plant material, not with the material that is Arnebia that is getting used here, and Dr. Shashi Bhushan can comment on that later. So I guess there's a patenting potential, and there is a huge application potential, both in foods as well as in personal care products, as long as its pH and thermal stability are not an obstacle. Yeah. Also think about what is the taste contribution of this, because you don't want something which will alter the taste of a food product or taste of lipstick and other things where this can potentially go. I'm not going in order. The third one I would like to comment on is the presentation by Dr. Gaur on xylobios. And to be honest, when I saw that presentation earlier, I didn't realize the value of it. When I heard today and when I realized that it has 96% plus purity from that one particular stream, and the cost of production is $8 per kilogram, and the market price is about $1,000 a kilogram, you are talking about a huge value addition. Yeah. So it has a purity, it has a high margin. So I think it's something which industry would be interested in. What I would urge, if possible, get some good clinical studies done as early as possible, either with few people or with whatever. But if you get a clinical evidence for this, I can see this becoming a commercial reality pretty soon. Encapsulation, I think Dr. Nene talked about it quite a bit. Both the presentations were quite impressive, and I really like those because of their potential. And one suggestion, looking at the future, would it be possible to combine these two technologies? If you can combine these two, nano plus your encapsulation using other functional polymers, it can be a huge platform in the foods area.
Sir, just 1 second. 1 second.
Yes.
We have actually created nano gel already.
Wonderful.
Okay.
Wonderful. Also think about encapsulating vegetative organism, because what you have done is you use spores. Yeah. Try vegetative organisms and try to increase the shelf life. I think if you do that, you're talking about an unmet need in food industry, which has been there for long time.
We will try, sir.
Good work. Good work.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah. And please patent it this time.
Yes.
Sure, sir. Sure.
Okay.
Now, again, coming to natural astaxanthin, again, an excellent work. Yeah. Using a particular, unicellular algae, the way they have done, I think it has huge potential. And what I liked about it is it is a naturally highly purified molecule. I don't think that point got noticed, because if you look at what is commercially used, that gives biomass of 9 grams per liter. yeah, and gives about 391 milligram as a yield. Whereas your strain gives only 0.75 gram, which is about let's say 15 times or 10 times less than the biomass that is given by the industrial strain, and yet you get about double the production. So you're talking about 20-fold purification to start with. So you're already in the higher league of purity. So if you take it further and you have the capability to go up to 100 liter, do some nano formulations, I think that can also sell like a hot cake, because it has applications in animal health, aquaculture, human health, and you name it. Yeah. So just to sum it up, really enjoyed all the presentations. All these presentations have significant content in it, which can be taken forward by the industry. And what I would urge the industry people is, and I come from industry, yeah, and I will urge all the people sitting there is establish those contacts. See, these are technologies which are at different stages, but at early stages, more or less. And what they need is some industrial input and somebody who's interested so they can take it to the next level. Yeah. And if you can do that, these are really good technologies which can create a difference in the market for the industries who want to take it forward. Yeah. So I will stop there, Dr. Premnath.
Yeah,
There's
thank
one
you,
point
Dr.
I would like to make that I will make only at the end if time permits.
No, I think those are very valuable comments, and thanks for also sharing your insights, because it gives new directions to where we can take it as well. So I think we are. I want to actually not prolong it too much, so I will give you the last word before we go to Pragnya. So, but we do want to hear what you have reserved for the end, and then Pragnya, over to you and team to take it to the end point. Dr. Sinkar, over to you first. You're on mute. Yeah. Oh, he's not able to probably just.
Now it's okay. Now I can do.
Okay.
Yeah, I can do it. Yeah, just for suggestion, Dr. Premnath and Pragnya, I think you have been doing it for some time now, this kind of events. And I know post the events we get a lot of queries, and we have been able to make some impact. I think moving ahead with the help of the industry participants, and that's more for them. If we can do it reverse, yeah, it will help us in a longer run. Because what Indian academia doesn't know at the moment is what industry wants. Yeah. Usually industry goes to academia to look for ready-made solutions. Yeah. But those are not available. If you tell them what you would need after 3 years, they can start working on it right now.
Yeah.
Yeah. So think about that. If you can create a showcase where industry showcases what the requirements are, and then academia based on that starts working on it. So another few years time, we'll be in a position that there will be a point of meeting, which will be win-win situation for both, just for consideration.
Yes, definitely. I think that is a very good suggestion. We will work on it. It's worthwhile to do that, and hopefully we'll get some good problem definitions to some of the researchers who can solve it. Can I just request everybody to come online for a moment so that we can, because all the speakers and the advisors, please. And yeah, Pragnya, would you be in a position to take a quick shot?
Yeah, I'll just try.
Yeah. Okay, I got something. Yeah, I think we have a new entrant now, so you have to do it again.
Yeah.
Have you taken?
Just a minute.
Pradnya ma'am, you're glitching, please. Yeah, that's.
Yeah. Is it okay? Sharvari, can you try some?
Yeah, I'm doing it.
My
don't
snip
worry.
tool is giving some error. I
Yeah.
don't know why.
Thank you. I think we're done. Okay. So
Yeah.
thank you very much. Thanks a lot. With that, we'll conclude today's tech showcase. We'll follow up all the requests we have got. I know Pragna has already received some. And we'll take it ahead from there as well. So thank you for all for participating. Thanks to the scientists who presented their work, and also generously listened to all the criticism that we gave them. So and of course, thanks to all the advisors who gave us inputs and also referrals to take things ahead as well. So thanks to our team. Over to you, Pragna. We can close now. Yeah.
Yeah.
Thank you, sir. Thank you so much. Just a minute, because
Yeah, sure.
Dr. Premnath and whole team has made it possible to present all this, because we don't know how to come to the industry and how to present all these things. They have put a lot of efforts for past, I think, 1 month we are doing on this. And thank you so much for the whole team. Thank you so much.
Thank you.
Thanks.
I would like to thank also to all Venture Center and team to really helping us to bring it to this point that we were able to make the presentation which we are not used to generally make in academics, right? Thank you.
Thanks, sir.
Yeah.
Looking forward for future.
Yeah. With that, I would like to close. I'm really grateful to the advisors who have been advising us since the beginning, inception of this Matchmaker, I would say that was last year. And I would like also to thank participants who were very patient in listening the pitches. And last but not the least, all our technology providers who have put in their hard effort in making the technology pitch possible and showcasing it to the audience today. Thanks all. We will close here.
All right. Thank you.
Thank you.
Bye.
Yeah.
Bye.
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 Pradnya, could you just stop the live stream?
Yes, I will just do that.